So, hello everyone and welcome to SOFiSTiK. My name is Adrian Błonka and hope you are doing well. Today we will continue our work with modeling the composite steel and reinforced concrete frame single span road bridge, and we will continue modeling the deck. And today we will focus on creating a concrete steel deck. So without any further elongation, let's get started, and remember about subscribing. Enjoy. So let's get back to our model. Recently we have created steel beams, including a steel web as a panel, and the flanges as the beam elements. And today we have to create just a concrete deck, including the kinematic constraints between the middle of the concrete deck and the middle of the upper flange. Looking at the target model, it should look like that in the future. We can see that we have steel beams right here, which we have already created, and also we have our concrete elements in between. We want to have a full control of the division in the perpendicular and the bridge direction. So for example, here we want to have 2 elements, sometimes maybe 3 elements, 4 elements. It depends on our mood and our needs. Also here usually I use the single partition, and somewhere between our first part which will be created and the second part which will be created in the next phase, we want to have some small gap which we have already defined in our model, but only we have to move those points at the level or the elevation of the middle of the concrete deck plate. Okay. And also we want to have full control of the division of these two parts. Usually I made them as a single divided elements, and also this one always I made a single divided, because there is no need to divide it in more elements, since this element is already quite narrow. So let's go back to our code, and let's find the definition of those lines that we have already created. They should be somewhere, I guess, here. Yes, they are. And there should be the points on the other side of our bridge, and those points are already rotated as they should be according to our bridge rotation angle. So let's collect the data from there, make this wire hidden, and also make this wire hidden of the other part. Also we as you can see, we have to divide those lines in the same division as we did for the girders. So we have to use this number as the division. So let's also create this number. This is an integer one, so use this component in the params, geometry, and not geometry but primitives, and here integer. So let's also make this wire hidden, so we have those data, and it should be enough. Also we should get the value of the distance between the middle of the bottom flange and the middle of the top flange. It should be somewhere. Let's find it. There is no information about that. Maybe it will be there. Flange height, web height, and so on. Okay, so let's collect this data, in this case as a number, because those numbers are not integer but they can be real. According to the coding, it can be a float number, a float data, something like that. Okay, so here's our web, and if you want to name this component and see which type of which information this component includes. We can just click the right button on the center of this component and change this text to, for example, web height in this case. And if you want to make this text visible, because as you can see it's not visible, only it appears when you click the right button on the middle. Then if you want to see it without clicking any button on your mouse, just use this icon with the how to say, paint box in paint, something like that. I also word, and now as you can see, the graphical representation of the component was changed to the text representation. So now we know what data is included in this component. So let's go to the wire and also make this hidden, and also we need to obtain the flange height, so flange thickness maybe better. So let's go to flange thickness. Okay, everything is collected in the meters, so as it should be. Okay, this is the division and those are the points. Okay, so now we can do it. Let's go down below and firstly move those points at the elevation or the height of the middle of the bottom flange height. So we have to create a vector, just collected these two data, the web height and the flange thickness, because here is a half of the flange thickness and here is another half of the flange thickness. So so summing those two numbers together, they will give us the just flange thickness. Okay, so let's just add them. Okay, create a vector in Z direction. So go to vector Z, connect, and now go to math and add. Just simply add a vector to the point, because summing vectors is like summing scalars. So you don't have to use component move object to move point. You can use move object to move lines, surfaces, and so on. But if you are operating with the principal elements like points, then you can just add them. Of course, you can also add vectors to vectors, because vectors are something like points in the definition on paper. Okay, so let's just do it. And now, as you can see, those points are moved to the elevation we needed. And let's do it also with the points on the other side. Okay, and now we also have to move them to higher upwards with the value of the half of the thickness of this concrete plate deck. So let's firstly define the thickness of the concrete plate deck, and it will be between 20 centimeters and 40 centimeters with the precision of 1 centimeter. Okay, so let's change it to 25 centimeters, and it will be the deck plate thickness in meters, of course. Okay, and now we have to just divide it by 2. Done, and also create a vector in this direction. Okay, so add this vector to this point. Okay, done. Now we are ready to create lines between these 2 points and points as a result of the division of those lines. So let's go to curve line, because line is also a curve. And firstly create line just right here, so at the higher level. Okay, it's done. Now we have to divide it, so let's go to the division and divide curve and divide it by this value. Okay, but before that we should firstly remove the first element of this list and have this lines without the first element, and also the second set of lines without the last line. Thanks to that, we will get the points at the most left side and the most right side without the first and without last and first element. In next step, we will divide the lines into the points, and then we will repeat this process of eliminating the first and the last element of our set of data to get bottom left points, bottom right points, top right points, and top left points. Having this 4 sets of points, we will be able to create a 4-point panel. Okay, so let's do it in practice, and I think it will be then better understandable. So first we have to eliminate the first and the last line and keep those two sets, and then divide them and repeat this process in the second direction. So first we have to do it in the perpendicular direction, this elimination, and next elimination in the longitudinal direction. Okay, so we have, I think we have created a component to do it. Yes, exactly. So let's copy it and reuse this component. Okay, and let's check what it has done. So we have without last element. So as you can see, this line is not included, and without first element. So now this line is not included. Fantastic. Now we have to use this one and repeat it for the second set of lines. Now we can repeat this process by eliminating the first points in this set and then the last point in this set, and repeat this process for the first set of lines. So also removing those points and those points. Let's check it out. So continue, and now we can see what I was talking about and what I wanted to obtain. So I will just show you those 4 sets of data. So here we have bottom left points without top one and the most right one. Here we have top left points without the most right one and the most bottom one. Here we have bottom right points without the most left one and the most top one. And finally the top right points without the bottom one and the most left one. Now we can create a panel going to surface, freeform, and 4-point surface, and create surfaces basing on these 4 sets of data of points. So let's start with the top right one. Top right is here. Now let's go to the bottom right. It's there. Here is bottom left. Now you can see the triangles, and the last one top left. Sorry. And the panels are created. Fantastic. So now we we can repeat this process for the second part of our bridge, but before that we will create the SOFiSTiK quad elements. So let's go to SOFiSTiK and structure and structural area, and in breadth you have to insert the panels. Usually the local X vector is pointed along the bridge, along the traffic line, so let's set it to Y, global Y direction. So dir X is here and the Z is usually pointed downwards, so it's correctly oriented. Material, I don't know if it was defined. Yes, it was. So this is the material number 1 and the reinforcement material is number 10. Fantastic. So here we should type 1 for material and 10 for the reinforcement. Fantastic. Thickness was defined previously, exactly there. Group is not necessary to define now, it will be needed in the future. Fantastic. So what is next? And of course I think one of the most sorry I forget about one thing. We also want to have a division between beams, so we have to also create a division right there. So let's think about it. We have points here and here, and how do we want to do it? Let me think for a little. I think this will be just a single element, this two, but also we can have a we want to have a control of it. We can make a set, I think. Yes. Okay, so let's create a line between those. So let's get a line between those 2 points, and also for this we will use our component we have created previously. So this component should give us this type of data. So first points without the last one and without the first one. Now we are able to create a line between them, more exactly. And now we want to have a control of the division of each line. But we know that we will set that the division between girders or the beams will be the same. So we have to collect the data about the girders and make this number lower by 1, less by 1. And we will also have a full control of the division of those two parts. Okay, so first we have to collect the data about the number of girders. So according to this component, it has 7 data: 1, 2, 3, 4, 5, 6, 7, and in this case number of girders is 5. So we have to reduce this number by 2 to get the number of girders. Okay, and also to get the number of spacing between girders, we have to even reduce this number by 1 more. So totally reduce this number by 3. Okay, so let's firstly get the information about the length of the set. So let's go to set, length of the set. It's here, list and list length. Okay, it should be 7. Yes, it is. Fantastic. Now we have to reduce this number by 3. So let's go there and just type x minus 3. Fantastic. Then we should get 4. Yes. Okay. So that's everything we needed from that part. Now we have to define 2 the division of this edge, division between girders, and division of this edge, interior edge of the semi-half of the bridge, of the half of the bridge, half part of the bridge, whatever. So let's create this component 1 to I think 5. It will be even two big numbers for this. So this is the division of external part. Okay, division between beams. Okay, and division of interior part. Fantastic. Let's set them to 2, 3, 4, just to have a possibility to distinguish those data. Okay, and we know that we have to duplicate this data, so division between beams 4 times. So let's go to the set, sequence, and component duplicate data. This component icon it always makes me fun. Those rabbits. Okay, and here we have data we want to duplicate, and in N we have to give information about the number of the duplications. So as a result we should get 4 frees. Okay, so we get, now we have to insert at the beginning of this data the division of the external part. So at the beginning, okay, by component insert item, it should be found here, as you can see. And now we have to also insert this division at the ending, so the -1 index. And as you can see, this list is done correctly. Fantastic. Now we have to use the component of curve division, and as you can see, number of these curves, in this case lines, is 6. This is exactly the same number of the divisions set. The length of the division set we have already created. So if we apply lines and this information, which have the same number of data, then this component should divide those lines according to this index. So the first line should be divided into 2 parts, and it is. Then next 4 parts of the parts between beams should be divided into 3 parts, and they are. And the last one should be divided by the 4 part. 1, 2, 3, 4. Exactly. So as you can see, it's working correctly. Now we can change it to, for example, not 21, of course, to 1, 2, and 1. And we should get something like that. Fantastic. Now we can create a set you can see that because we have divided this part into 2 parts, it created 3 points, and this point is the same point. So the beginning of this part is the ending of the previous part. So this point is duplicated. The same, this one, this one, this one, this one, and so on. So if you want to get rid of those points, you can flatten this list, go to the vector. In points you have a cool duplicate component. Give there's some small tolerance, like 1 millimeter, I suggest. And now you can see that the number of items was 16 as an input for this component, and the output should be less 11 in this case. Fantastic. Now we have to also sort those points, and we want them to be in this order, so 1, 2, 3, 4, 5, and so on. So the number of so the position in our list is rising with the rising of the global x coordinate. So let's go to the point and deconstruct the point to get the information about this y coordinate of each, sorry, not y but x coordinate of each point, and go to set and use component sort list in the list subcategory. As a key, we should give this component information about global x coordination of our point and the points itself for a input. And as a result, we get a set of the points that are sorted, and we can check this out if we use just an list item, and let's check it from 0 to, for example, 5. So this is our first point in our set. This is the second one, third one, fourth one, fifth one, sixth one, and so on. So as you can see, those points were sorted correctly. And now this whole group of components can be created as a one cluster. So let's do something like that and select those components, click the scroll button and create a cluster. Now as you can see, I think we can make it even better. So let's make it in the correct order, like that, like that, like that. Okay, and now we can do it even worse. Okay, now. Okay, fantastic. So this is our division of external part, division between, and division interior part. Okay, list of points from the beginning, and this is data. Fantastic. So now we can use these points instead of these points. Okay, but before that we also have to create the same case for the points on the other side. So these points, so let's just include them, and as you can see, everything was done. Fantastic work. Now let's go there and there, and now we should enjoy the panels even with division between beams. Fantastico. Okay. And we can implement it into our SOFi MSHC component and check if everything is done correctly. So let's go to SOFiSTiK. Where is it? Not this one. Sorry, give me just a second. Okay, I have it, I think. Okay, this should be this one. It should be this one. It's loading. Okay, so our TD file is here, and let's calculate it. Come on, come on. Yeah. Okay, and let's check it out. Come on. It's not this one. Of course, this is the target one. Why is loading so slow? Okay, now it is. I think I have to update Windows. Okay, So as you can see, the deck was created, but this division is too high because I made a small mistake. It's a simple one, don't worry. Let's go here, and in the SOFiSTiK structural area component, we have to choose a single quad element in the mesh option. So let's go to the single quad element and go and give this information right here. Now we have to go back there, refresh, of course, always. And as always, thanks for watching. No, I was joking. It was a reference to Vsauce. Okay, go to system, and now everything is beautiful. So we have the division as we wanted it to be, and now we have to make one more thing without making the deck for the second part. So we have to create a kinematic constraint between the deck plate and the top flange of the beams. So let's go then here, and we have to create lines at this level, at this elevation. So let's create a lines right here. Come on, why it's so lagging? I don't know. Maybe because I didn't turn off this computer for last 1 week. Maybe. Okay, let's go there. Come on, yeah. And remove the end lines of the set because we don't need them for our purposes. So let's check it out if it is working correctly. Yes, they were deleted. And now create a division which is the same as it was for our deck. Maybe I will close my another two opened Rhino files, and now it should work faster. Yes, it is slightly. Okay. So now the division is done. It's exactly as it was for the top flanges. And now we have to repeat this process for the top lines. So we could use this one, but it will be just easier to create lines between those 2 points set as we did previously, but without the division between the points. So let's use those to set and repeat this process by eliminating the end lines, so like that, and divide it along the bridge. Now we are ready to create the kinematic constraints. So let's go to SOFiSTiK again. Kinematic constraints, so-called couplings, are here, and I recommend to start with the top points and go to below, because points at the level of the concrete deck will appear in our model in next step. So it's natural that we want to define the displacement of the new points as a displacements of the points that already exist. Okay, so I will even change the order, so top one and bottom one, so from the top to the bottom. Fantastic. Fix ppmm, so the full pp, so translation, and mm rotation, because pp is connected with the force, which is connected with the translation, and mm is connected with the moment, which are connected with the rotation. Okay, and group will be defined in next episodes. So yeah, now those couplings are ready. We can just double click here to click here on this line to create this pill-like component and add it by clicking the Shift key, holding the Shift key more exactly. Okay. I don't like this mess. Let's get rid of this one. So I will hide those our inputs from these ones. Okay. Hide and again. Add there, and let's check it out. So let's go to SOFiSTiK, Teddy, calculate, and F12 again, and go to system and change the view by clicking the cross section to get the panel view, or the more simple one view. And as you can see, those kinematic constraints should be created correctly. We can check it out firstly by making them smaller. Now you can see the chains, it's better. And let's check the start and the end point of each kinematic constraint. So at the first we have 1181, and this is also one of the points of the squad, 1181, and also here 1181. At the bottom we have 1182, and in this case is also one of the points for this beam, 1182. So this kinematic constraints is created between those two elements physically. So there is no a small negligible gap, and so we are now sure that the structure is connected with each other. So now let's go back and create it for the second part, and in the final step we will create them by connect them by fulfilling this gap. Okay. So honestly, for this part we only need this 5 data component, this one which is constant of course, and this division which can be different. It depends on of our needs. So we can just copy this one, sorry, even with them, let's group them just like that, copy and substitute these points by the points of this set. So let's go, this one are the points on the other side, this is the division along, and this division should be the same as it was previously. So we can even substitute this point, this by this one, because it's the same. Fantastic. This one is also the same as it was here, because the height is the same for beams on these two parts. Here is a division which can be different, so I will keep it then. So I will give a possibility to change it, but there is thickness. I will create a number component and substitute it by this value, because the thickness of the plate deck is the same for two parts. Okay, and also add it to group. Fantastic. Now we have to just substitute these two inputs. It's that easy. So this one instead of this one. Okay, boom. I know, complete mess, but give me a second. And now we have to substitute this one by this one. Okay. Now it's not a complete mess. As you can see, it's perfect. Okay. Now, sorry, one more thing. We have to also substitute the length of this set for the duplication component. So there's also one thing to do to change, and it should be here, list of points from the beginning, which is the same as here. Okay, and let's substitute it. Not this one, of course, but this one. And now this line from here disappears. As you can see, the previous one and the new one, the correct one, of course. Okay, now it's, I think, much better. Yeah, exactly. We can also check if we have control of this division. Yes, and this change doesn't interrupt the division of the first part, so they are separately defined. Here also everything is working correctly. I think this is external, this is interior one, so we have to change the order because this one is just creating division in the interior part, and this one is creating division in the exterior part. So we have to change it. Okay, change the order. I think that's all. Single, quad, ta-da-dam. Okay. And now we have to insert this data right here, go to Teddy and apply F12 system, and it's done correctly. Fantastic. Now we have to only create this fulfilling of this gap. So for this case, for this purposes, we have to get the interior edge of the first part and the interior edge of the second part and divide it in the same division as we have done it previously, and connect it by the 4-point component surface. A 4-point surface component. Okay. So here, no, not here. Here we have our set. Let's go to set and let's take the last one. So let's go closer and click this and click this plus button, which will add new output. So we need -1 from this list, and because this is so, because those lines are organized in rising global X value, so that's why we need the last one, and in this case, in this part, we need the first one. So the first one should be there, and we don't need the last one output. Okay, so we have them. We can also make the wire hidden, and let's use the line just to show what we want to get from this component. And now let's divide them. I think using this component will be also okay. Fantastic. And now we have to delete the first point and then the last one, and repeat this process for this line, and then we will get 4 sets of points, and then we will create our surface as we did previously. Okay, I will show you what we have obtained. So first, last, and again first and last points. Now let's go to curve and 4-point surface, and let's start with the right top. So this one, next right bottom, next left bottom, here are our triangle, and the last point is this one, so the left top left, and now we have the needed quads, and they are the same as this one. So let's copy it just like that, thickness as widen as hidden, and implement the change into the code. Let's go. Yeah. Done. And as you can see, this gap was fulfilled. Now we can, just for better meshing, we will raise the density of the mesh along the bridge, because I think those how to say, those quads are too rectangular. There should be more square one or something like that. So let's go here. Here is our division. Division has its origin here. This one has its origin right there. So there is a longitudinal division. Okay, and let's check it to, for example, 15. Much better, I guess. Yeah. And let's check the results. Fantastic. As you can see, division is the same along the bridge for the beams and for the deck elements, and also kinematic constraints are created exactly in the nodes. Fantastic. So I think it's everything for this part. Yeah, we can also make some grouping also here, and this whole part will be a family of the concrete deck and smoothing as a one part. Fantastic. Also here maybe something could be done. So here some kinematic constraints, flanges. So more or less we can say that this everything is a one family of data. So the beams, and we can also name it maybe with bigger font height, yeah. Beams. Add to group. And add to group. Deck concrete plate. And now, looking at this, we will know which component should be where the component we want to find is located. Too complicated sentence to say. Okay, so that's it. So that was everything I wanted to show you in this tutorial. This one is shorter than the previous one because I didn't have to explain so much for the beginners. I hope it was helpful for you, and this is the last episode I had to remake because this part, the part 2, was also firstly made in Polish, sorry, but also in Poland. It's also true, yeah, and the next one are in English, and the rest and the remaining ones will also be made in English, so I don't have to remake them, so you can keep going and enjoy the next episodes now. So again, thank you for watching. Please remember about subscribing, leaving the like button, and leave me some comments with some suggestions, which I will then and then I will fulfill my duty and respect those comments, because as you can see, according to the comments you have left in the previous videos, you wanted to make a remake of the first 2 parts of the series, so I made it and finished it. So as you can see, I'm listening to those suggestions. So again, thank you really for watching, and See you again. Bye bye.